we're going to be starting Fish Kill Day 4, an intro to solutions and concentrations. So we want to figure out what is concentration and how can it be calculated. We're going to be looking at something called molarity today. So thinking about water quality, as we look at the White River fish kill, water must be tested continually to ensure that the concentrations of contaminants do not exceed the established limits. Possible contaminants might include metals, pesticides, and bacteria. So pesticides are going to be like ag runoff, bacteria, is there something that contaminates the water, metals, thinking like lead pipes that might be eroding, different things affecting water quality. So here's a water quality report for Visalia. So looking at, they look at radium and uranium, some nuclear particles that occur naturally. Let's see. We have arsenic, barium, cyanide, fluoride, nitrates, and perchlorates. So you have some of these. The ppb is parts per billion, and the ppm is parts per million that we see on this chart. And for more, you guys can click here and go to a link, and it'll take you to the water quality report. And then for concentration, concentrations refer to the amount of solute that is dissolved in a solvent. So solute is like the solid or liquid that is put into the solvent. Solvent is like the larger amount of liquid that is dissolving the solute. When dealing with contaminants, concentration is an important variable to consider. Concentration can be expressed in many different units. It can be grams per liter, parts per million, moles per liter, which is molarity. Very often you'll see it as like parts per million. And then in chemistry, moles per liter as well. Describing concentration. So a concentrated solution would have a large number of solute particles dissolved in the solvent. So there would be a lot dissolved in it. It would be a higher concentrated. A dilute solution would have a smaller number of solute particles dissolved in it. So dilute solution would have a low concentration, whereas a higher concentration would have more solute for the amount of solvent present. So dilute is like watered down. To dilute your juice, you add water to your juice to dilute it. So when dealing with contaminants, a more concentrated solution is usually more toxic than a diluted one. So think if something happens up more towards Anderson for the fish kill, as it travels downriver, the more it disperses through the water, the more dilute it becomes. So here we're going to look at which solution is more dilute, solution A or B. So here we have more solvent, here we have less. They have the same amount of solute though, same yellow dots. So A is going to have a higher concentration and B is going to be more dilute. It has more water per solute in it. Calculating concentration using molarity. So molarity is a ratio, similar to when we did stoichiometry. It's a ratio of moles of solute to liters of solution. So moles of solute, this is what is being dissolved, to liters of solution. And you'll see an M typically, a giant M is the symbol for moles per liter here for molarity. In calculating molarity, one practice here, we have calculate the molarity of a solution in which 116 grams of sodium chloride is dissolved in enough water to make 4 liters of solution. So step number 1 is to convert grams of solute to moles of solute. So we're given, here's our given, is 116 grams, and then we'll use the liters after we've converted those grams. So we need grams to turn into moles. So you'll put your given here at the top. Then, using the periodic table, you will calculate the mass for sodium chloride. So sodium is 22.99, and chloride is 35.34. So if we add this together, if we use like the whole numbers, 35 plus 23, we would get 58 grams. So that's just using our periodic table how we've used in the past. So that's your molar mass. So grams given divided by molar mass gives you per 1 mole. So you multiply the top and divide by the bottom. 116 grams times 1 is 116. Divided by 58 is going to give us 2 moles of sodium chloride. So for every, we're going to calculate our molarity for 2 moles of sodium chloride solute for 4 liters of solution. The concentration of that, 2 divided by 4, is going to be 0.5 molar. Is going to be our final answer. So when solving for concentration, that's 0.5 molar. We'll do one more practice. So on here, calculate the molarity of a solution in which 20 grams of sodium hydroxide is dissolved in enough water to make 0.25 liters of solution. So again, this gives you grams, and you have the liters. So liters is what we need, because it's moles per liter, moles of solute per liter. So we know the bottom here is going to be 0.25 liters of solution. So to get the mass, you're going to take 20 grams of sodium hydroxide. Sodium is 23. Oxygen has a mass of 16. That's the atomic mass. On the bottom of the periodic table is a smaller number. The top number is the number of protons. So 23 plus 16 plus hydrogen has a mass of 1.01 or 1. So if we add all three of these together, so 23, 16, 1. That will give us 40 grams as the total mass. And the mass is equal to 1 mole. 1 mole of a substance is equal to the molar mass. So here we're at 20 times 1 is 20. Divided by 40, that's 0.5 moles of sodium hydroxide. So to find our concentration, we have 0.5 moles of sodium hydroxide solute dissolved in 0.25 liters of solution. That has a concentration of 2 molar. And again, finding molarity, moles of solute divided by liters of solution. And usually you'll have to convert grams to moles and then just divide by liters given. Sometimes you'll get milliliters, and you'll just have to times by 1,000 for the milliliters, or do a conversion from milliliters to liters.